Where do you see this example?
The one, yeah, the one that your cursor is on.
Here? Okay. How would you like to simplify it in further?
3a to the power of 6.
Oh, wait a sec. No. So we cannot add two exponents if we have different base, right? So 3 is a separate thing and a is a separate thing, right? You cannot add, for example, x's to 5's, yeah, because you don't know what's a. So very important rule. Of course, you can say that a to the power of 2 times a to the power of 3, and then you just add, you simplify it, oh, it's a to the power of 5. But if you have a to the power of 2 and some b to the power of 3, you don't know, because you don't know what's b. Is it clear? So all of the rules, if you take a look, all of the rules that we covered so far, so it's whether it's adding the exponents, so multiplication, or dividing, so subtracting the exponents, or even the here, yeah, that's what we covered today. You have only one the same number. So very important. You can simplify only if you have two uh, forms of the same number. So just the exponent differ. Is it clear, Hansi?
Yeah.
Okay, that's why you cannot explain. Okay, Constance, you have a question. Go ahead. Yeah, sure. Go ahead. Not a problem. Okay. Alan, are you there? I can see you. Yeah. Okay. Another example for you. So I see you get this law here. Okay. So let's say I have 2a times b squared and everything squared. Give it a thing. Huh? Oh, I encourage you to use laptops, or it might be more convenient, but give it a try.
2ab to the power of 4.
Wait a sec. Apply the rule. Apply the line here. Each term should be squared. So
2a to the power of 2 times b to the power of 4.
Now, depends how you write it. So it's 2a to the power of 2 times b to the power of 4. This part is very well. Now, here, again, we have the same thing. So it's kind of, law within the law. So now if you simplify it, what does it equal to? So apply the exponent to all of the terms. Give it a try, Alan. So take a look at the line here. You have to apply the exponent to all of the numbers inside. So 2 needs a square and a needs a square as well. Is it clear?
So
Right?
4 to the power, so 4 a to the power of 2.
2 and b to the power of 4 remains as before. Is it clear? So this one was tricky because I didn't put a dot in here. But in math, when I multiply, I don't have to put the dot. So it's very common that I just omit this dot. Okay, but still, if you apply the rule, apply the law, you have to put the exponent into each and every term, even if it's just a 2. Okay? James, example for you. 3a, or maybe 3x square times a, and everything squared. Give it a try.
I think it's so 3x2 times a, or is it?
Apply the rule. Apply the rule. Don't combine everything at once, because then it's difficult to work with.
No, is it 3 times 2, or is it 3x to the power of 2?
Oh, what's the difference, James? What's the difference between 3x squared and 3 times x squared? It's the same. Yeah, what I just said. In math, it's the same. 2x is the same as 2 times x. Right? It's the same. In math, in textbooks and everywhere, you will see this dot being omitted. That's why I teach you without this dot very often, so you get used to that. Okay.
I
So
it's 3x 2
how about applying this separately to all of the terms? So this 2 will apply to 3 separately. Yeah, 3 is a different independent term. Yeah, it's a different species. And also 2 will be applied to x squared and 2 will be applied to a. Is it clear?
Okay, so 3 to the power of 2
Mm-hmm.
times x to the power of 4
Mm-hmm. Very good.
and a to the power of 2.
Yeah, very well. Perfect. Yeah, now 3 to the power of 2, you can say it's 9, and then x to the power of 4, and then a to the power of 2. Yeah, I omitted the dots because you can. Okay. Linlin, let's give it a try. Linlin, I will show you something like this. I have a b squared times c squared and everything squared. Give it a try. Linlin. Yeah?
I think it's uh um
Take a look at the previous example.
okay a b squared then wait um
Maybe if I put a dot in here, it will be easier for you.
so it would be I think in parentheses ab squared and then that would be
Wait a sec. Of course, like okay, guys, you're going in different direction. All of you make kind of a similar mistake. So of course, I could just multiply it all here, but it doesn't give me any more information. I could say it's a, b, c, like b squared, c squared, and everything squared, right? But does it give me any more information? It's the same. I just omitted the dots. Instead, I want to make use of this law. Yeah. So from one common exponent, I want to make two separate ones, right? So instead, I will just apply this exponent to all of the terms. So to the a, to the b squared, and to the c squared. Is it clear?
yeah.
Okay, so try London. It will be equal to
So a squared
okay,
times I think b to the power of 4
4, right? Exactly.
and then times c to the power of 4 as well.
4 as well, right? Because you apply the exponent to each and every term, right? So very often it will be useful with when one is our variable like x or a or b, and the other one is a number, like we did a few examples in here. But yeah, that's the concept. Okay, did I omit anybody? James, one example for you as well. Let's say we have 4x cubed to the power of 2, something like this, now with a cube. Give it a try, James. And I can't see your, like, could you turn your camera? I can't see you.
4. So I think 4 to the power of 2,
Uh-huh.
x to the power of 2, and 3 to the power of 2.
Oh, wait. Is this 3
Oh,
separate or it's an exponent?
it's x to the power of 5.
5 or 6? Remember the previous law?
Oh.
Oh, so if I have an exponent to the power of, let's go step by step. So as you said, it's 4 to the power of 2, and now put brackets. Brackets are your greatest friends, okay? Put brackets around everything you can to make it clear, okay? And then you apply the rule, the exponent. It helps a lot because you just see, oh, it's not just 3 plus 2, it's 3 to the power of 2, like x3 to the power of 2. So that's the rule. So it's 4 squared, and James, x to the power of what?
X to the power of 6.
6, because 3 times 2 is 6. Okay, so I know at this point we combine multiple laws, so it might be difficult, but don't feel overwhelmed. go step by step, step by step. Okay,